Okay, so let's move to question 13. Let's see how we can solve the question if we have rational function. So we have question 13 and 14. Let's choose 13 for example. So over here, let's change this. Okay, so in here, this is 13. Now, first of all, finding the domain. The domain, it will be r minus the zeros of the denominator. Now for the denominator we have x, so x equal to 0, that means we have 0 only. That means in here the domain is r minus the 0. Now, so we have finished from the domain. Now we have to find f prime. So f prime is equal to the denominator multiplied by the derivative of the numerator, which is 2x minus 5. Okay, so minus the numerator x squared minus 5x plus 4 multiplied by the derivative of the denominator, which is 1 over the denominator square. Okay, now we can simplify it. F prime is equal to x multiplied by 2x, x multiplied by minus 5x, so this is 2x squared. Then we can x multiplied by minus 5, which is minus 5x. Now we can enter the minus inside this quadratic, which is going to be minus x squared plus 5x minus 4 over x squared. Now 2x squared minus x squared, this is equal to x squared. And also we have minus 5x with positive 5x, so eliminated. Then we have minus 4, and in the denominator we have x squared. Let's make the derivative equal to 0. Okay, from the denominator, from the numerator to find the zeros. So the zeros, so over here zeros. So x squared minus 4 equals 0. I can factorize this to x minus 2, x plus 2 equals 0. So that means I have x equal to positive negative 2. From the denominator, the undefined value, it will be x squared equals 0, which means x equal 0. Now for positive negative 2, they will be accepted. For x equal to 0, it will be rejected because it's excluded from my domain, from the original function domain. Okay, so now let's go ahead and find f double prime. Okay, that will be by finding the derivative of this, the denominator multiplied by the derivative of the numerator. So this is 2x minus the numerator square minus 4 multiplied by the derivative of the denominator divided by 2x over x to the power 2 square, which is x to the power 4. Okay, now let's simplify it a little bit. So that will give me in here, this is 2x cubed, which is 2x multiplied by x squared. Then I will enter the minus and 2x together, so that will give me minus 2x multiplied by x squared, which is minus 2x cubed. Then minus 2x multiplied by minus 4, this is equal to positive 8x over x to the power 4. Now this with this eliminated, and the x with the 4 in here, that will leave me with x to the power 3 in the denominator. So f double prime equal to 8 over x cubed. Let's make it equal to 0. Now the zeros, I will make the numerator equal to 0. which is impossible. It is not going to be equal to 0. Now for the undefined value, it's x cubed equals 0, which means I have x equal 0. So this is going to be rejected because it's excluded from my domain. Now to find the concave up, concave down intervals, now even the 0 is excluded, you can put it on the number line, but you will not take it as inflection point. Be careful from that. So just to test where is the concave up, concave down intervals. That's it. This is the concept. So I'll grab the number line. So in here I have 0. Okay. Now this is rejected, be careful, and I will test the value of the second derivative from the right of the 0 and from the left of the 0. From the right of the 0, if we substitute any value, let's say positive 1, it will be 8 over 1 cubed, which is going to be positive, so that will be positive. And from the left, if you substitute minus 1, it will be negative. So in here I have concave down and concave up. So I will write directly in here concave up from 0 to infinity and concave down from minus infinity to 0. Okay, now after that we can say that no inflection point. I know that you will say that, teacher, I have changing from concave down to concave up, why the 0 is not, we cannot consider it as inflection point. I will say because it's not included in the original functions domain. Okay, so you cannot take it. So after that, if if we would like to calculate the local points, so I'll find directly f double prime of the critical numbers, so f double prime of positive 2 and f double prime of negative 2, and I'll find them. So in here, where is the derivative? That's it. So let's substitute it directly in the calculator. So let's keep this. Let's see the calculator. My function is alpha x square minus 4 over x square, alpha x square. Okay, now calculate at minus 2. Okay, again. Oh, sorry. Okay, so calc again, minus 2, yes. Oh, sorry, we have to substitute an f double prime. F double prime, sorry, we wrote in here. Oh, okay. So again, it's 8 over x cubed. Yes, that's the correct expression. Okay, so cubed to the power 3. Now calc at minus 2. This is minus 1. So minus 1 at minus 2. And what about the second one? Calc at 2, 1. So minus 1 and 1. Okay. So this is 1 and this is minus 1. So in here, this is local minimum. This is local max. That's it. Done. Now we have finished the question. So inshallah, next we will move to another question, which is the graphing question. Just let me give you the answers for the questions now in here. Okay, so we solved all of them. Okay, so starting by questions 9, 10. That's the solution. Now in here, actually, I found only the local points, local maximum, local minimum. If you would like to find the intervals, you can do this. You can write the intervals directly of the concavity, concave up, concave down, all of these things. Now in here, you'll find me just focusing on the local points where we can find them. So in here, you can find all the questions. This is question 11, question 12. Okay, and this is a question 13. Okay, and this is question 14. That's it. So inshallah, see you in the next video.